Hello everybody, this video clip still on chapter 6, okay, but this is should be the last one. This one will be word problems, okay, and mix between the one with your function is given by z equals to f of xy without any constraint, and you are going to find the extremum value by using, the critical point finding from f sub x equals to 0, f sub y equals to 0, and then you are going to check whether your critical point will give you a max or a min or a saddle point by the same direction second derivative competing with the different direction second derivative square, and the one that is given by z equals to f of xy with a constraint g xy equals to 0. We are going to construct a capital F, okay, this one using the so-called Lagrange multiplier equals to a small f minus lambda g, and then you are going to find the critical point of this small f under the constraint by using a capital F sub x, capital F sub y, capital F sub lambda, make them equals to 0, okay. Let's look at the first example. It says that a manufacturer produces two products, okay, and the demand of the first product depends on the price of the first product and the price of the second product, and the demand for the second product as well, okay. Of course, your Q1 and the Q2 are the quantity that the quantities are sold, okay, for the first and the second product, but your P1 and the P2 is the prices, okay, of the first and the second per unit. So if you want to find the total revenue, what's the revenue? Don't forget that the revenue is the money that you obtain from all the selling. So of course the revenue should be found from the number of quantity that you can sell multiplied by the price of that quantity per unit, and the second quantity, the second product as well. And your Q1, it is in terms of AT to P1 and P2, and P multiplied by the price of the first product, and the quantity Q2, it is 30, and P1 minus P2, okay. And you can calculate it a little bit further to have your negative 2 P1 square, you see here, okay. And then sorry, this one I forget to multiply by my P2 here, and the second term you got negative P2 square, okay. And then you also have your, you see, P1 and P2, and here you got your P1 and the P2, okay. So you add them up, so you have 2 P1 P2, and we also have this term for 80 P1 and this term for 30 P2, all right. And if it is saying that the cost to produce the first product is 40 per unit, and the cost to produce the second product, it is 30 bahts per unit. So can you express the total cost in terms of P1 and the P2? So the cost, it is of course 40, this is to produce one of the first product, right? But you need to produce Q1 of the first product, okay, to be sold, and 30, it is 1 unit for the second product, but you actually produce Q2 of them. So it is 40 multiplied by your Q1 again, it is 80 minus 2 P1 and P2, and 30 with your 30 with your Q2, which is 30 P1 minus P2, okay. So you manipulate it a little bit, to simplify it. So you have negative 80 P1, you see, negative 80 and positive 30, so you have negative 50 P1, and for your P2 you got 40 P2 and negative 30 P2, so you have positive 10 P2, and you have 3200s with 900s, so you have a total of 4100s. Okay, so as you have your revenue and the cost, you of course can find the profit, right? You of course can find the profit. What will be your profit? The profit, which is depends on the first price and the second price, it is of course the revenue minus the cost. Okay, so the revenue, you have negative 2 P1 square, you have negative P2 square, you got plus 2 P1 P2, and you have this one 80 P1 minus, okay, don't forget that you have a minus sign here, minus negative 50, so it becomes a plus 130 P1. You got this one 30 P2 minus 10 P2, so you have a 20 P2. That's it. And then a minus 4100s, right? So here's the profit function. Of course, we are going to ask for the maximum profit, right? So we are going to find your derivative of the profit with respect to the first price, which is negative 4 P1, you see here, and then also a 2 P2, and then 130, okay, 130 here, make it equals to 0, and your derivative with respect of the profit with respect to the second price, okay, here you have negative 2 P2, you got here the 2 P1 and 20, make it equals to 0. Okay, and you may simplify it to have your negative 2 P1 P2 equals to, this one is negative 130 over 2, right? Because you divide each and everything by 2, so you have 65. Is it? But this one you got P1, you can leave it as 2 P1 minus 2 P2, okay, equals to negative 20. You see it like that. Okay, this one. Okay, so it means that you can simply do the addition, right? So that you can get rid of your 2 P1. Okay, so we have negative P2 equals to negative 85, or your P2, of course, it is 85, right? So if your P2 is 85, what's your P1? So you can just simply take this one, right? Take the first equation. Okay, you can simply take this one for your P1, or I mean maybe it's better to take your second equation. Okay, actually your second equation saying that P1 minus P2 equals to negative 10, right? So it means that your P1, it is negative 10 plus P2, and your P2 is 85, so your P1 is simply 75. Okay, so it means that your critical point, it is P1 and P2 equals to 75 and 85. So you need to check whether this critical point really gives you a maximum profit or not. So you are going to test, okay, your profit, okay, a derivative of the profit with respect to the same direction, P1, P1. So here it is your P1, so you have negative 4. And profit, okay, derivative with respect to P2, the same direction, okay? So your P2 is right here, -2, and the profit again, but with a different direction, P1, P2, the second derivative. So you still have this, which is 2, and then you do the test, okay, by computing the same direction second derivative and a different direction second derivative square. So you have -4, -2 minus 2 square. So it is 8 minus 4, which is again positive. So it means that the same direction wins. So if the same direction wins, just look at one of them, okay, which is negative. So it is downward. By downward, it means that you have a maximum. So this means that this critical point, okay, really gives you a maximum profit. Okay, so here the price that will give you a maximum profit is P1 75 per unit, P2 $85 per unit, baht per unit. How many units of first product and the second product should be sold? So it is a Q1 and a Q2, right? So don't forget that your Q1 depends on the first price and the second price, which is 80 minus 2 P1 and P2, is it? You see here? Okay. So it is a what? 80 minus 2 P1 is 75, P2 is 85, okay? And you can use your calculator to calculate what it is by your own. We good? Okay. Or you can say, hey, this is let's see, this is 165, this is 150, right? This is 150. So you end up with 15 units. Okay. How about your Q2? Your Q2, you go back again, is 30 and P1 and subtract your P2. So your P1, it is 75 minus your P2, which is 85. So it's simply 30 minus 10, so it's 20 units, okay, to be sold to obtain the maximum profit. Are we alright? This problem? So this problem has no constraint, but it's just the same old profit problem, okay, which is depends on the revenue and the cost subtracted each other, and you find the critical point, okay, by using the first derivative, and you test the critical point by using the second derivative. All right. Let's look at this example. It says that this company produced stainless steel for, of course, a domestic and international markets, okay, and the price per metric ton and the demand quantities for each market are governed by this following relation. So the price of the domestic market depends on 630 minus 40 Q1, and for the international market, P2 depends on 800 minus 50 Q2. Of course, your P1 and your P2 represent the price per unit per ton, okay, at 1,000 baht per unit when it's sold domestic and international respectively. And your Q1 and the Q2 is a unit of the quantity sold at 1,000 tons per unit. Of course, I mean inside, which is a domestic, and the outside, which is international. And the total cost function, okay, the CQ, it is 20 plus 150Q. We want to find how many tons, okay, should the company sell in each market to, of course, attain the maximum profit, okay. So if you want the maximum profit, first of all, you need to find your profit itself, okay. So the profit right now should depends on your quantity, the first quantity and the second quantity in each of the market, and it is depends on the revenue minus the cost, okay, and the revenue is the money that you can obtain from all the selling, right? So it is your P1 and the Q1 and your P2 and the Q2, and then minus the cost, which is 20 and 150 Q, but this Q is the total cost. I mean, either you sell to domestic or international, you still need to use this cost, right? So it is a Q1 and the Q2 together, okay. So here your Q1, it is 630 and 40, I'm sorry, your P1, it is 630 minus 40 Q1, and your P2, it is 800 minus 50 Q2, and then minus 20 minus 150 Q1 and minus 150 Q2. So you can calculate it further by having negative 40 Q1 square, negative 50 Q2 square, and then of course, I mean 630 Q1 and then subtract 150 Q1, so you have what, 530 and then 500 and another 20, so you have 480 Q1, is it? And then you have your 800 Q2 and then take away another 150, so you have 700 and another 50, 700 and another 50, so you have 650 Q2, is it? And then this one, don't forget, minus 20, so this one is your profit, depends on Q1 and the Q2, right? So if you want to find the maximum of your profit, you need to find your critical value, okay? So it is the derivative with respect to the first quantity, the first variable Q1. So you have negative 80 Q1 and then 480, you see, here's a Q1, there's a Q1, and then make them equals to 0. So immediately your Q1, it is 480 over 80, which is 6, is it? How about your derivative with respect to Q2? It is 100 Q2 and 650. So it means that your Q2, it is 650 over 100, which is 6.5. Okay, so here is your critical point, which is 6 and 6.5, and you need to check whether your critical point really gives you the maximum of the profit or not by computing between your same direction second derivative, okay, capital P derivative with respect to Q1. So here it is negative 80, and then the second derivative with another same direction Q2, there it is negative 100, and your different direction Q1, Q2, which is, I mean, you can look at this one, it has no Q2, so it goes to 0, and then you just check your same direction competing with your different direction square. Okay, so it is 80, negative 100 and 0 square. Of course, I mean, it doesn't matter, but it is 0, I mean, it is positive. So it is positive, so it means that the same direction wins. So look at one of them, which is P sub Q1, it is negative 80, so the curve is downward, so it means that this critical point really gives you a what? A maximum profit. okay, a maximum profit, right? So what will be your what is it that you need further is the corresponding price per ton, okay? So it means that, so let us interpret first. This is 6 and 6.5, okay, which is your Q1 and Q2, okay, will give a maximum profit, okay. What was the unit of the Q? The Q is 1,000 ton per unit, right? So it means that you should sell 6,000. Q1 is the inside domestic, right? 6,000 tons domestic, and you should sell 6,500 tons international, okay. At which price? At the price of, so your P1, so let's go to P1 again. Your P1 is 630 minus 40 Q1, 630 40, and your Q1 is this number 6, okay. So it is what? I mean 630, so it is 390, and your P2, the price number 2, it is what? 800 minus 50, Q2 is 6.5, okay. So it is 6.5 and 50, so it's 800 minus 325, okay, and it gives you 475, okay. So what is the interpretation? Don't forget, look at it carefully. Your P1, it is 1,000 baht per unit, okay, the unit of prices per ton, okay, at 1,000 baht. So it means that you are going to, actually the selling price, it is 390,000 baht, okay, per tons, right? And this one also, it should be 475,000 baht per tons as well, okay. That's the selling price that will give you the maximum profit, okay. So this problem is the same old relative extremum, okay. You are going to find without any constraint, without any conditions. We get. Let's look at this example. This one is pretty straightforward because it says that the production function is given by this f of xy. Of course, the x and y are the amount of two ingredients, and it says that they have the production factor constraint, okay, which is 2 of the x and 3 of the y must be equals to 74. So it means that this one, your g, okay, the constraint, it is 2x 3y minus 74, and then let it equals to 0, okay, you just move it there. So to use the Lagrange multiplier, you need to construct the capital F, which is a small f minus lambda g. So your your small f, it is given pretty straightforward like this, minus lambda, and your g, it is 2x 3y minus 74, make it equals to 0, okay. So this one, your f sub x, okay, to find the critical point using the Lagrange multiplier, you need to find the capital F sub x, which is 2x and 5y, and then minus 2 lambda, let them equals to 0. Your f sub y, okay, capital F sub y, it is your 5x and 8y minus 3 lambda, let them equals to 0. And of course, capital F sub lambda, it will be the same as your constraint with a negative sign, okay, make it equals to 0. So don't forget that the main idea is to find your x and y, okay, but in order to get your x and y, you may need to look at these two equations first, okay. So the first one you got 2x, and the second one you got a 5x. So you may need to multiply this one by 5, and you multiply this one by 2. So upon multiplication, you got 10x 25y equals to this one 10 lambda. Okay, you move it the other side. This is 10x 16y equals to this one, you move to the other side 6 lambda, and then you let you do a subtraction so that you can get rid of your x, right? So upon subtraction, you have 25y and then plus 16y, so you have 41y equals to 4 lambda. So it means that your y is simply 4 lambda over 41. How about your x? You can just using this first one to obtain your x, okay. So your x is simply 2 lambda minus 5y over 2, okay. So your y is this one, so you multiply by 5, so you have 20 lambda over 41, this divided by 2. So you do a simplification, it is 41 lambda 10 lambda over 41, so it is 31 lambda over 41, is it? That's your x. So after you got your x, okay, as well as your y, you can just simply plug in your x and y into here, right? Because your x and your y now depends on one single parameter lambda. So it says that 2 of the x and 3 of the y simply equals to 74. So it is what? Your 41 can be multiplied over, and then this one is what? 62, right? And 12, okay, which will give you 74 again. So it means that the 74 cancelled, so you end up with your lambda equals to 41. So after you got your lambda, you can figure immediately what your x and your y is. So it means that your x and your y, which is 31 lambda over 41 and 4 lambda over 41, it is 31, okay, because your lambda is already 41 and 4. This is your critical point of your f, okay, under this constraint. Two x 3y equals to 74, okay. And again, you got only one critical value, and you need to find the greatest output possible. So this one will of course give you the greatest output. Okay, it will be f at your x to be 31, your y is 4. So what's your output function? So it is x squared, and then here, right, 5x and y minus 4y squared. Okay, then you can use your calculator, or you may just leave your answer like this. This is the greatest output. Okay, so this is example number 3. Now let us look at another example. This one is saying that the open top rectangular, so it means that there's no lid. Okay, this is a rectangular box, is to have a volume of 6 cubic feet. Okay, the cost per square foot of material is $3 for the bottom, $1 for the front and the back, and 50 cents for other two sides. You need to find the dimensions of the box so that the cost, of course, is minimized. All right, you need the cost to minimize. So let us draw this box a little bit. Okay, so here's the box. Okay, has no lid. Okay, so let's say that this one is x and y, and the height is z. Okay, and let's say that here is your front, there is your back. Okay, and this one is your bottom. Okay, it's your bottom. So it says that the first condition saying that the volume must be 6 cubit. So it means that your x, y, z together must be 6. Okay, and the cost, okay, the cost depends on the bottom first. The bottom, it is $3 per square foot. But right now, what's the area of your bottom? The area of your bottom depends on the x and the y, right? So it is the 3xy. The area of the front and the back, it is 1, and it is the yellow here, right? Okay, so the first yellow, I mean the front, it is depends on your x and your z, and your back, it will be the same area, right? So it is twice of xz. Okay, because in the front and the back, and then the two other side, it is 50 cents, so it's 2.5, and the two other side actually is the one without the highlighted, so it depends on the y and the z, so it is 2yz. Okay, because you got two sided. Okay, here's the cost, depends on 3 variables. Okay, but this is a constraint. Okay, you look at it as a constraint because these 3 variables multiplied together must be 6. So it means that your constraint, it is x, y, z minus 6 equals to 0. So if you use the, and this one can regard as the small f. If you want to use the Lagrange multiplier, so you need to construct the capital F, which is a small f minus lambda g. So your small f, it is this one, 2xz, and this is 1, right, yz. Okay, minus lambda of x, y, z minus 6. And then you need to find the derivative with respect to the first variable x, which is 3y. So, okay, 2z, you see, here's the x, there's the x, and also this one, minus lambda yz, make it equals to 0. F sub y will be 3x, will be z minus lambda x z, make it equals to 0 as well. F sub z, it is right here, the 2x, it is right there, it is a y, minus lambda of x, y, and of course f sub lambda, it is negative x, y, z minus 6 equals to 0. Okay. All right. So this is maybe a little bit difficult, okay, as you look at it at the first place. It seems that, hey, I mean, there's a lot of variable, okay. It is x, y, z as well as the lambda. So what are we going to do? Okay, what are we going to do? Okay, let's see. This depends on how good your algebra is. Okay, this is x, y, z equals to 6, right? That's one of the condition. That's one of the condition. Okay, and then if you really take a look, you'll see that here, okay, on each one of your equation, you almost have x, y, z. Okay, but for example, the first one you are missing the x, you see. The second one you are missing the y. The third one you are missing the z. Okay, okay. What we can do is to, manipulate, okay, by multiply each one of them by the missing variable. Okay, so for example, if you multiply the whole thing, okay, by x, so you have x and then 3y plus 2z equals to lambda of x, y, z. So it is 6 lambda, right? Because your x, y, z equals to 6. This one you multiply by y, so you have y and then 3x and z equals to 6 lambda as well. Okay, and the last one, if you multiply by z, you have z and 2x plus y, the whole thing again equals to a 6 lambda. Okay, equals to a 6 lambda. All right, so it means that this pair, you can pair them up. Okay, you can pair them up because both of them equals to the same quantity. So it means that your left hand side here, 3xy and 2xz must be equals to 3xy plus yz. All right, so the 3xy cancelled, the z cancelled, so it means that your 2x must be y, right? Your 2x must be y. We get, okay, and this one again, you can pair them up because they equals to the same 6 lambda. So you have 3xy and yz equals to 2xz. You see, you multiply, and yz, so the yz cancelled and then the x cancelled, so it means that your 3y equals to 2z. Okay, your 3y equals to 2z, but what's your y? Your y is actually 2x, so it means that your z equals to 3x. You see, your z equals to 3x. We get, but your x, your y, your z together must be 6. Okay, So your 6 is x, y, z. Your x can be the x, but your y, it is 2x. Your z must be 3x. Okay. So it means that right now your x must be, I mean, this is 6, right? So you got your x cubed equals to 1. So your x is 1. So upon you know your x, immediately your y is 2. And after you know your x, immediately your z is 3. You see, because your z is 3x. So it means that the critical point for the small f, okay, is, remember where's your small f is the cost function over there, you see. So it is 1, 2, 3. And because you got only one of them, only one critical point under this constraint, okay, under the constraint saying that x, y, z must be multiplied together, must be 6. Okay, so it means that this one will give you the minimum cost of the material to construct the box. Okay, so this one will give you minimum cost of producing a box with volume equals to 6. Okay, with volume equals to 6. So your x must be 1, your y must be 2, your z must be 3. All right. So we are going to stop this clip right here first, and we are going to continue some further example with you on the next clip. Bye bye.